Good morning, student. Today I am here to explain you some very interesting and important basic concepts of refraction in our daily life. We will also solve some numericals for the competitive exam also, student, in this class. Okay, student, listen it very attentively to gain the basic logic behind the refraction and its effect in our day-to-day life, student. So today I will talk about image formation due to refraction, student. Okay, image formation due to refraction. Student, you see the figure on the screen. I have shown one line state that is an interface. Above there is a air and below there is a water. In that water there is an aquatic animal, say fish I have taken, or any object you can take. And the top I have drawn the eye of a person who is observing it. Now student, suppose the water is not there. Then what is the case? Then here I have drawn the figure. The eye will see directly like this. The rays will go from fish or that animal to the eye, and the image will interpret it and it will see the image as in daily life. But student, in this case the water is there. The ray will not reach like this as shown in the figure. The ray will refract. Here student, see. Now student, yesterday I told you the logic behind it, how the ray refracts. Snell's law. Okay student, the product you have to remember, mu sine theta is constant. Now here the light is traveling from the water to that person. Okay, so the first medium is water here, which I have shown in the arrow. Now since the water has a higher refractive index, the theta corresponding to mu will be less as compared to theta corresponding to air. Student, remember student, mu sine theta, Snell's law, that product. So this refracted ray I have shown it. In direct way, it is bending away from the normal since it is going from denser to rarer. Okay student. Now student, remember the technique of image formation, how our brain interprets. Our brain, what it does is it traces the rays in the backward direction, and where it meets it shows the image there. So I have shown it, the dotted above. The apparent position of the fish I have shown it. See student, it will be above the actual position. Can you see it student? The apparent position of the object will be above. Means he will see at a little less depth as compared to actual depth. That fish is lying in a much more depth, but due to refraction, he will see at a much lesser depth, student. Okay, student, this one example I have shown it. Now another example, see. In the first example, the observation was from the rarer medium, student. Okay. Now student, here see a swimmer is swimming in the water, and above in the air, say bird, or you can say object, because bird or any other object which is in the air, this swimmer is observing it, student. Again student, due to refraction, see what will happen. Now the rays are coming from air. Rays are coming from air to water, so the light will bend towards the normal, student. Light will bend towards the normal, and from the swimmer side, if you see, he will see the image of the object little above. Can you see it, student? He will see little above than the actual height. Means the height will increase in this case, student. So got the idea, student, what has been explained? In the first case, the observation was from the denser medium. The observation was from the in this case, student, second case, the observation was from the denser medium, and the object was in the rarer medium. So he is seeing the image little higher. Okay. In the first case, the observation was there from the rarer medium, and the object, that fish, was lying in the denser medium, student. So he sees the image at a little less depth. This is two important fact you have to remember, student, and you have to know the logic also behind the refraction, student. Now student, see this position where the image is there. Okay, that I am taking the height of the image hi. Okay, and where the object is there, that I am taking as the height of the object. Okay student, I'm measuring it from the interface, the height of the image, height of the object. Now see student, here again I have drawn the figure. The light is traveling from denser to rarer medium. I have drawn one normal, and you can see angle of refraction R I have shown. Okay, and by geometry that R is shown in the downside also. That I is the image student. Okay, you trace the backward, you trace it backward, the refracted ray, you will get I. O is the object, I is the image student. Then student, if you see from the figure, I have applied Snell's law student, Snell's law. And what is Snell's law? Product of mu and sine. So I have written mu1 sin I is equal to mu2 sin R. Now one more thing about mu1 and mu2 student, to make it very easy. You remember one thing, where the light is traveling in the first medium, that has been given name as mu1 now in this figure. Okay, and where the light is traveling in the second medium, that has been given name as mu2. Okay student, this basic you remember. So here the first medium was in the denser medium. There I have written mu1 because light was traveling first in that medium student. So I have taken mu1 sin I is equal to mu2 sin R. The I have shown in the figure student, this product. Now see, some mathematics is there student. If I and R are very small student, I can replace it by tangent I. If you don't understand tangent, don't worry student, it is in trigonometry, and at present it is not so important also. You just you observe, the in place of sine I can write tan theta if the angles are very small. Then student, I have taken the triangle, you can see ABI. So in trigonometry we have tangent angle defined as perpendicular upon base. Okay student, means from that right angle triangle, if you take the ratio of perpendicular and base, I will get tangent of that angle. Again student, I am saying if you don't understand this tangent, don't worry about it. Okay, at present it is not so important. We have to see the final gist of it, which is very interesting. So student, I have written tangent, and then I have found out the formula tan R tan I. The formula is perpendicular upon base. If you see the triangle, perpendicular is AB and base is AI student. AI means height of the image, that I have written. Okay student. And by Snell's law, in place of sine tan I have written. Now student, this is the very important. This is where you have to understand. See student, what I got. HI upon HO. HI means height of the image and HO means height of the object. And what is mu2 means? Mu2 means student, it is that medium where the light is traveling in the second medium, it is student. And mu1 is where the light is traveling in the first medium, that you have to consider it as mu1. So this is the basic formula you have to remember student. What? That height of the image upon height of the object is equal to mu2 upon mu1. And what is mu2 student? Remember mu2 student, mu2 means second medium, second, and mu1 means first medium. So even suppose the denser medium is first, okay, there you can write mu1, because in the previous video I have taken mu1 as a rare medium. So remember student, it is not a fixed thing. Mu1 mu2, they are not fixed, named as rare and denser. Okay, so in this formula mu1 mu2 simply means first and second medium student. Now student, I will solve one numerical student. Suppose the height of the object was, now before that student, one more thing, height of the image, height of the object. Height of the image I have written it as apparent depth. Means what? Apparent depth means it is appearing to the person who is observing it, it is not the real, and their image is formed student. So I have given it named as apparent depth, and below actual depth. So this one formula is there, apparent depth upon actual depth is equal to mu2 upon mu1 student. Now student, I have written one numerical value. See, I have written 10 into 1 upon 4 by 3. Have you understood student what this value is? This 4 by 3 is a refractive index of water, and I have shown you light is traveling from water only, because the person who is seeing, he is in the denser medium. So light is second medium, the person is where the air is there. So in place of mu2 second, I have written 1 student, means 1 is refractive index of air, it is the second medium student. And mu1 is, it is the refractive index of water, it is the first medium, because light is traveling from water to air. In air that person is standing. Okay student, now what height you will see? See 7.5 meter, means it will appear less depth. Already I told you student, it will appear to be at less depth, student, because here light is traveling from denser to rarer, student. So this is the gist, student. This formula you catch it, student. Apparent depth, actual depth, mu2 mu1. Again I am repeating it. What is mu2? It is the second medium. What is mu1? It is the first medium. It is not connected with rare or denser. Okay, student. Now let's solve another question, student, related to that. See here, a very interesting question, student, and it is a this question mainly it is for the bright learners, the higher part, okay, above 90% student, though every student can see it, but it is for only those students. See, student, what is the question? Find the gap between the two aquatic animals when seen from top. Okay, see the figure, student, see the figure. It is a water, two animals are there. First O1 I have shown it, O2, and they are at 10 meter from the top, okay, and 10 meter below the second object. Means the second object is at 20 meter from the surface. Okay, student, these are the two objects in water. These are the two objects in water, and the refractive index is 4 by 3, and this is where the person is in the air. Okay, student, so mu I have written 1. Now remember, student, where the light is traveling? Light is traveling from water to air. So this water is the first medium, student. Remember it. Water is the first medium. Now see the formula, student. See, for the object H1C, HI, height of the image, height of the object, mu2 upon mu1. Again, student, mu2 is the second medium. Remember, second is air, so I have written 1. Mu1, first medium, 4 by 3. Height of the object 10, it is given from the surface 10 meter below. So see, height of the image 7.5 meter. Means the object O1 will appear at a depth of 7.5 meter from the top surface of the water, means little above than the actual. Now student, I am solving it for second one. See the same formula, hi upon ho. Now ho is 20, student, 20. This is what we have to understand. See the figure again. See, O2 is at 20 meter depth from the surface of the water. So now ho is 20, student. Rest things are same. Now see, student, how much I am getting hi, 15 meters, student. 15 meter means when the person is looking it from the above, so from the surface of the water it will appear to be 15-meter depth, though actually it is at 20 meters, student. Means that object or that animal is actually at 20-meter depth, but that person will see it at 15 meter. Can you see, student, how the numerical is solved so easily? And the question is find the gap. Now student, I think you understood how much is the gap. This you can find out how much is the gap, student. So once again I am repeating it, student, how the conceptual numerical is solved in this case. See, this is the formula, hi upon ho, mu2 upon mu1. Hi is height of the image, height of the object. Mu2 is second medium, mu1 is first medium refractive index. Whether the person is lying in the rare or denser. Suppose as in case of swimmer, student. Swimmer, okay, swimmer is in the second medium and the light will travel from the air. In that case, student, the mu2 will be the refractive index of water. In case of swimmer, if you see, means the person is observing from below the water. So light would travel from the object which is in the air. So in that case, air is the first medium and the water will be the second medium. So you can find out how much height that object will appear for a swimmer who is inside the water, student. From the same formula, student, you can find out. But you have to understand the basic logic behind it, student. Only this, then only you can solve the numerical. Due to refraction, the object is appearing at a different depth or at a different height. When the object is in the rarer medium and the person is in the denser medium, he can see at a greater height. But when the object is a denser medium and the person is in the rare medium, he can see at a lesser depth. Both the this principle will follow this formula, hi upon ho, mu2 upon mu1. In any case, you can apply this and you can find out the actual height of that object which is appearing in the other medium, or actual depth you can calculate which is appearing in the other medium. So can you see, student? It is so much interesting, the phenomena of refraction of light and how the physics and mathematics is helping us, student. So try to revise it on your own words and try to express it on your own words, student. Then only this class will be successful. And remember, student, when you are revising it, don't see the book, don't see the any copy. Revising means sit alone and just try to recap what has been said or what you understood. That is the main revision, student. And if you follow this method 2 3 times, it will go to your subconscious mind, student, and you will remember it forever. You can solve any numerical of any kind. So this is a based competition based numerical was there, student. Okay, student, thank you. We will continue with the next topic in next class.